All right, so depending on how big your dog is going to get as a full-grown dog, that affects how much you feed your dog as a puppy. And so this is like, if this is how much you feed your dog, this is how much the dog will weigh as an adult. So, did you guys get 11.277 kilograms? Ish, but okay, good. Now, I don't really know like the conversion to kilograms, but somebody in my last class, like for that golden retriever, that is 30 grams. They looked it up, and that's going to be like a 66-pound dog. So they were thinking that it's an 11-pound adult dog. That's not what it means. So it's different. Obviously, it's a different unit of measurement. All right, so on this one, did you guys get these weights? And it's okay if you round it differently. I rounded differently originally, and then they pointed out to me last class that it does say to round to the nearest tenth, but it doesn't really matter if you round it differently. Is that what y'all got? Okay, now this next question is really the most important one to me out of all the questions on here. So if you want your dog to weigh 15.2 kilograms, how many calories should you feed your dog? 1,000, yes. So we want this, so that is what you would feed your dog. All right, and then the ideal weight of a golden retriever is about 30 kilograms. How many calories should you feed your golden retriever to achieve its ideal weight? And we're going to show how we get our answer. So we want 30 to equal our K over 130 raised to the 4/3. Now, I saw some notation that some people did in the calculator I had never seen before. I didn't even know it was a thing. But what some people in my last class did, and your Algebra 2 teacher may have taught that to you, I don't know, is they took the 4/3 root. Have you guys ever seen something like that before? Did any of you do the 4/3 root? Okay. I didn't even know you could do that. What I did is I thought about raising it to a power that whenever I multiply these two powers together, I would get 1. So what would you multiply 4/3 by to get 1? 3/4. So that is how I've always done it. Obviously, your calculator understands it the other way, and you wanted to do it that way, it's fine. Either way, 30 raised to 3/4, or the 4/3 root of 30 is going to be 12.819. All right, and then what would you do with that 130? Multiply by it. And so this is how much you should feed your dog if you want it to weigh 30 kilograms when it grows up. Which is kind of a better equation. Is that not what you... Oh, sorry, I was looking at the next one. That's going to be an underweight dog. It's not going to be an underweight golden retriever. There we go. Is that what y'all got? Okay. That was going to be the Schnauzer. All right, so we'll do the same thing for the Schnauzer. I have a hard time saying that name. All right, we're going to do the same thing. We're going to raise it to the 3/4. That's a 3/4 there. It really doesn't look like it. I'll rewrite it. And then we're going to multiply by 130. All right, that is the 675.5 kilocalories. Because you only want a 9-kilogram dog. Right, so now we're going to write an equation that gives the amount you feed a dog based on how large you want the dog to be when it's full grown. And so on these, W, the weight, is the 30 and the 9. What was the first thing we did to those weights? We raised it to the 3/4. So that's the same thing you would do to the W. What was the second thing we did to solve it? Multiplied it by 130. So that is the formula, which I think is probably a more useful formula, that if you know how much you want your dog to weigh as a full-grown dog, that's how much you would feed it. Not the other way. All right, so that K function is actually the inverse of the F function that we started with. And so this notation, raising to the -1, is the inverse notation. And so I don't know if you guys got to 5, but if you wanted to make sure that this really is right, what could you do? All right, you could just plug in stuff we already did. So for 9 kilograms, you should get 675.5. Or plug in 30 and see if you get 1,666.419. So just check it in the other way. Right, so this whole lesson is about inverses and finding inverses and verifying inverses. Okay, so on the back, the main thing I want you to understand about inverses, and I'm not sure if people really get that this is what an inverse is, but an inverse will undo everything the original function did. So if you have a function and you plug in 9 and you get 30, that's not what happened on the other one. On the inverse, you should be able to plug in 30 and it turns it back into a 9. So that's the whole purpose of an inverse function, is to undo what the original function did. So we're going to jot that down. Inverse functions undo the original function. All right, and one of the things that you're asked to do with inverse functions sometimes is to verify. So to verify inverses, you're going to do, you're going to do two things. You're going to do the composition. You're going to do F inverse of f of x. So composition is what we learned at the end of last week. So put the original function into the inverse, and everything gets undone, like everything kind of cancels away, and you're just left with x. And then you have to do it the other way also. So you would do f of f inverse. You do all the work, everything kind of cancels away, and you're just left with x. And you may or may not have done that last year. I know in Algebra 2 last year you did learn about composition, so you might have done that with inverses. I don't really know. All right, and then to find inverses. It's a 4-step process, but 3 of the steps are super easy. All right, the first step is super easy. You're going to replace f of x with y. That is no big deal. right, step 2, you are going to switch x and y. That is also no big deal. All right, step 3 is the most algebraic step where you have the most work. So step 3 is to solve for y. And then the last step is another super easy step. You're going to replace y with f inverse of x. So you replace y with the inverse notation. Do y'all remember doing that? Finding inverses last year a little bit? Maybe? Well, we definitely are going to do different things than you did last year. So a lot of these examples are probably not what you did, which is good. It's good to learn new things. Okay, so on number 1, based on the table below, we want to find g inverse of 12. Now this is the table for g. They're asking you to find information about the inverse. And so if you're finding g inverse of 12, they're asking you to find g of what x value is going to give you 12. So what x makes g equal to 12? What do you guys think? 16. So that means g inverse of 12 is 16. All right, so it's reverse of what you're thinking because the x's and y's are switched. All right, now last class they were a little confused by that. So we also went ahead and we just made a table for g inverse. And I'll probably, on your assignment, ask you to do that also. So on this table, it's going to be the table for g inverse of x. Now finding inverses with tables is super easy. I'm making it sound like everything is super easy today. It's not, but tables are. So if you have a table and you want to find the inverse of it, all you do is switch x and y. So all you do is make the y row, that now is the x row. And then the x row is now the y row. All right, if you do your table, g inverse of 12, when x is 12, g inverse is 16. So we were right with what we said before. Okay, so on number 2, we have this is the graph of h. They're not asking us information about h. They want us to know h inverse of 2. So same thing that we were just saying, like with the table. If we're doing h inverse of 2, you're trying to figure out what x value is going to make the graph equal to 2. What do you guys think? Right here's 2. What x value makes it equal to 2? 5. So, whoops. H inverse of 2 is 5. Alright, so I changed your notes, but I didn't change what I have up here. So you guys don't have this question about Fahrenheit and degrees Celsius, which is fine. I didn't like it, so I took it off. So this is your number 3 about the ambulance, right? Okay. Alright, so f of x gives the distance in miles that an ambulance can travel within x minutes of receiving an emergency phone call. Interpret the meaning of f inverse of 26 equals 20 in context. So f of x is going to give a distance. So x is the minutes, and it equals miles. They're not asking us about f, they're asking us about f inverse. And so if this is the case for f, which one of these is minutes for the inverse? The 26 or the 20? The 20, because on the inverse, the x and y switch. So the 26 is miles. And so we're going to interpret this in the meaning of the context about how long and how much time and how far the ambulance has traveled. So it would be something like after 20 minutes, the ambulance traveled 26 miles. All right, are you guys okay? All right, we have one more. We're great on time. Oh, my iPad is locked up. Okay. All right, so we're going to find the inverse. So we're going to do all the things. The first step is to replace f of x with y. In this case, it's g, but we're going to make the g of x become y. So y is going to equal 1 over x plus 2. All right. The second step is to switch x and y. All right, so I'm going to make my y an x, and I'm going to make my x a y. Nothing else gets switched but those two variables. You don't move numbers with them, you just move the variables. All right, and then this is the longest step. We're going to solve it for y. So what would you guys do first? If there's something in the denominator and you don't want it there, what do you do with it? You multiply by it. So the first thing we're going to do is multiply by that y plus 2. We are not going to distribute. I think you guys have a little bit more room than I do, but I'm not sure. All right, it's going to be easier for us to not distribute in this case. So if I'm not going to distribute that x, and I want to solve for this y, what would you do now? I didn't hear you, but I'm going to say you said divide by x. All right, now what do I do with that 2 to solve it for y? If I don't want the 2 and it's being added to the y, we're going to subtract it. All right, and then the last step is another easy step where we're just going to replace y with this. In this case, it's going to be g inverse. All right, that's my inverse function. So that function undoes everything that this one does. So for example, if I put in, let's say we put in 3 for x, that's going to give us 1/5. So this one I should be able to put 1/5 in for x, and it should give us 3. That's what an inverse does. All right, one more. This one's kind of long. So the last step is we're going to use compositions to verify that they are in fact inverses. So that's this part right here that we wrote in dark blue. we're going to have to do two compositions. So I'm going to move way over here. So we're going to do G inverse of G of X first. Alright, so G of X was our original function, 1 over X plus 2. I'm going to color code it like I did it when we learned it. Alright, so G is what we found over here. It was 1 over X, but instead of X, we need to write this. We need to write what we got there, which is right, and then the rest of G is just a minus 2. Okay, so how do you simplify this? Like, how do I divide 1 by this fraction? I think so. Multiply by the reciprocal. Multiply by x plus 2 over 1, yes. So 1 times x plus 2 over 1 is just going to be x plus 2. Alright, and then we have the minus 2, which just gives us x. That's what has to happen if they are inverses of each other. But we only did it one way, I have to do it 2 ways. Alright, so the other way is G of G inverse. Alright, so G inverse was 1 over x minus 2. So I'm going to take G, the original function, and where I have x, just right there, I'm going to put in this light blue. Alright, and then that G still has a plus 2 down there. So the same operations are going to happen here, but we're going to do them in different order. So in this case, the first thing we would do is go ahead and subtract those 2's, or combine those 2's. And then the last thing we would do is to multiply by the reciprocal. And it does equal x, just like it's supposed to.